So in this video, we're going to simplify these two algebraic fractions, and we're going to go through that by factorising the numerator and the denominator, and then cancelling through. So let's start off with this first one. We've got 8x squared take away 50 in the numerator, over 10 take away 2x squared take away x. So, first of all, let's focus on the numerator. Now, the numerator, we can already spot, because we've got the 8 and the 50, that both of those are even, so we could factor 2 out of both of those terms. So we could write that as two lots of 4x squared take away 25. Now 4x squared take away 25 we need to spot as a difference of two squares. Okay, so what I would want to do is I could already spot that this is going to be two lots of, and that's 2x plus 5, 2x minus 5. Okay, so going through that process for the numerator. Now the denominator, I don't like its current format, okay, because we don't have the x squared term first, so I'm just going to rewrite that as minus 2x squared, then the minus x, and then the plus 10. So I need to factorise that. So let's do minus 2 times 10. So minus 2 times 10 is minus 20. So we're looking for two numbers that multiply together make minus 20, but add together to make minus 1. Okay, so 4 and 5, minus 5 and 4, that works out. So minus 2x squared take away 5x plus 4x plus 10. So factorising the first part there, we can factor out minus x, and then we'll have 2x plus 5. And we can factor the 2 out there, so two lots of 2x plus 5. So we're going to have 2x plus 5 as one of the brackets, and the other bracket is minus x plus 2, or 2 minus x. So we can now spot that we've got a common factor of 2x plus 5 in the numerator and denominator. So I can divide through top and bottom by 2x plus 5, and we'll be left with 2 lots of 2x take away 5 over 2 minus x. Now you could leave it like that. I'm going to multiply that bracket through by the 2, so I get 4x take away 10 over 2 take away x. Okay? Now that's just an aesthetic thing of not having a bracket in the numerator if I don't particularly need one. But if you've left it as two lots of 2x take away 5 in the numerator, that'll be fine. Okay, so that's the first one. Now the second one. So the second one actually has a property where all of the terms in the numerator and denominator are all even. So I could divide through everything by 2 first. That would make my life easier. So I'm going to do that. So we're going to get 4x squared plus 12x plus 9 over 54 divided by 2 is 27. So 27 take away 12x squared. Right, okay. Right, let's keep going then. So with the numerator, let's go into factorising that first. So we've got 4 times the 9 is 36. So we're looking for two numbers that multiply together to make 36, but add together to make 12. So it'd be two positive numbers, not 12 and 3, not 18 and 2, 6 and 6. Almost didn't spot that. Okay, 6 and 6. Right, so we can write the numerator as 4x squared plus 6x plus 6x plus 9. So factorise this half, and I'm going to get 2x plus 3, and that's 3 lots of 2x plus 3. So the numerator is going to factorise the 2x plus 3 times 2x plus 3. So we're going to have 2x. I'm going to write it like that. You could, of course, do 2x plus 3 all squared. Okay, so that's that bit. Now let's focus on the denominator. 27 take away 12x squared. Now it's kind of looking like difference of two squares, but not quite yet, because the 27 and 12 aren't square numbers. So what if I divided through, or factored out, 3. 27 and 12 both have a common factor of 3. So 3 lots of, and I'd have 9 take away 4x squared. Now that is the difference of two squares, and that's nice. So this would be 3 lots of 3 take away 2x and 3 plus 2x. Okay, now 2x plus 3 and 3 plus 2x are the same thing. They're just written round the other way. So we can divide top and bottom by 2x plus 3. So I'm going to be left with a 2x plus 3 in the numerator, and then this in the denominator. Now I could leave it like that, just as I said you could leave 2 lots of 2x minus 5, or you can multiply through by the 3. I'm going to multiply through, and I get it into that form there. Okay? And so that is that fraction simplified.